All right, we've got two problems here, both of which I'm going to use the calculator for. First one is giving us a position function saying that a particle is going along the x-axis where time is greater than 0, and they want to know what the velocity of the particle is at the instant that acceleration is 0. So what I'm going to do is I'm going to type this function into my y1 using x values, of course, because the calculator won't graph t values. So x to the fourth minus 2x cubed minus x squared plus 2. And because they want to know when acceleration is 0, I'm going to turn off my position graph and I'm going to turn on my second derivative or my acceleration graph. Then for my window, I want to start at 0 and I'll go to maybe like 8. I have no idea where I need to be, so I'm just guessing right now. And now I'm going to check it out. This is acceleration graphing, and I see I have one place right now where acceleration is 0, and I'm guessing that is the only place because the way the wording is, it says at the instant when acceleration is 0. So once it stops graphing, I'm going to do second trace and find the 0. Okay, second trace, choice 2 is 0. Left bound, I need to come to the left of that number, which looks to be about 1 point something. Keep on clicking left, and there's my cursor. Okay, left bound, then right bound, guess, and it's at x equals, thinking, 1.1455. So what I want to do is evaluate the velocity function at this time. So I'm going to go to my home screen by hitting second mode, and I'm going to evaluate my y2 function. It's y2 because that is the first derivative on the graph. So it was at 1.1455. At least I think that's what it was. Let me check. 1.1455 is probably not the correct answer. So now I have to do this again, guys. Remind me to write it down. My x value is 1.1455. So going to my home screen, 1.1455. So look at that. I should have looked at my answer. I did have the answer right here. It was A. Sorry for the waste of your time. Okay, so now they want to know which functions are differentiable for all x. So I look at these and I want to figure out where there might be an issue. And I don't know if this one's going to be an issue at all, so I think I'm just going to look at the graph of it, the square root of x squared plus 1, and turn off the second derivative graph, and let's just do a zoom 6 here and look at this. Aha, so the question is, do I have a sharp corner here, or is that a soft curve? Let's do this. The issue looks to be at x equals 0. So if I go to my home screen and I take alpha trace to get my y-vars, and I take y1 and I evaluate it at 0, it gives me a value. So it says that basically the derivative, oh wait, it wants to know if they're differentiable. So I need y2 at 0. So is the derivative able to be evaluated at 0? And yes, the slope there is 0. So let's do that. So we know, first of all, that number 1 works. So it can't be 2 only. It can't be 2 and 3 only. So I have 3 options left now. And we're going to put in the second of the graphs. This one looks like if there's any issue, it would be at 0 because of this absolute value. So I don't know if you know this, but if you go to Math, Number, choice 1 is ABS for absolute value. So you see it puts in the absolute value there. And I'm going to do times x. I'm going to go ahead and look at the graph. Looks like maybe that is differentiable. So I'm going to go back to my home screen, and I'm going to plug in alpha trace y2, and I want to do y2 at 0. I want to know if the first derivative is defined at 0. And it is. Looks like we're good there. So we don't have any issue with this guy. So 2 also works, so it's not 1 only. The only question is, does 3 work? Is it 1 and 2, or is it 1, 2, and 3? So go back to y equals, and I already have the absolute value, so I'm going to do times e to the negative x. And I'm assuming that the issue here would also be at the absolute value, or at 0, excuse me. So looks like there might actually be an issue here, but let's go ahead back to the home screen and let's try to evaluate the first derivative, excuse me, y2 at 0. And that has an error. So the third one here is not differentiable, so the answer has to be C, 1 and 2.